Absolute legends. These are both solutions of water, and because they're the same thing, they would have the same boiling point and the same freezing point. Now we've changed the boiling point of this solution because it has molecules of sucrose added to it. Consider an atomic vision of those two solutions. The blue dots represent the water molecules. We are expressly viewing or visualizing the solvent molecules in this example right here. This, one of them contains only water, the other one contains water and sucrose. And sucrose, I'm just going to give red dots for right now, just for simplicity right here. Now, two things to note about a solution that has stuff solvated in there. There are new interactions between molecules. So for example, this dotted line here represents an interaction between the solute and the solvent that is not present in the pure one. So that is going to affect part of the thermodynamics or energy of what we're trying to do. Also, because there is molecules of sucrose dissolved in this beaker here, there are going to be some sucrose molecules that find their way to the top. In the act of boiling, molecules of water need to be able to go from liquid phase to gas phase at this top interface. If some of those spaces are occupied by sucrose molecules, there's just more gatekeepers preventing water molecules from passing into the gas phase. So we need to add more energy to get past this right here. Two things I want to convey with this picture here: new interactions between solute and solvent, and a and a space limiting at this gas liquid interface. We can calculate the predicted boiling, we can calculate or predict what the boiling point would be for this solution right here. We would do that with this idea of boiling point elevation. Because of new interactions and because of limited spaces right here, we know the boiling point is going to be elevated above 100 degrees Celsius. So that's something we need to state right off the bat here, that we know our answer is going to be a little greater than 100 degrees Celsius, like it has to be. All right, we have 40 grams of sucrose. I'm going to put that in red just as a reminder that red is what these dots are right here. And we have 335 grams of water. I'm going to write that in blue because water's blue. 335 grams of water. And again, we're trying to find what the boiling point is. It's going to be above 100 right here. Now, water's boiling point can be predicted on a linear basis from a constant that is known for water. So this number you would have to look up or Google, and it is a physical constant about the behavior of water, and that is 0.512 degrees Celsius per molal. This is a terrible, ugly looking unit. It's got, first off, it's got a fraction. I hate it. It's got temperature and then molal. What the heck's molal? I hate compound units, so we're going to accordion that molal out. Molal is moles per kilogram. I want to find my final answer in units of degrees Celsius. So this looks like a great place to start my scaffold because it has degrees Celsius in the numerator. And we should also, excuse me, we should talk about what these moles and kilograms are referring to. The moles is referring to the solute, or in this case, sucrose. And the kilograms is referring to the solvent, water. Kilograms of water I need to get rid of. Great, that's already in grams. Love it. So I'm going to put the grams down here. 335, excuse me. 335 grams of H2O. Just to kind of think about my reasoning here, I had this smart start because the temperature is in the numerator, and I want to get rid of the kilograms of solvent and the moles of solute. Grams, kilograms are just close cousins. 1,000 grams is 1 kilogram. And I'm just doing my conversions in the scaffold because I don't want to pick up my calculator. I don't care to right now. I need to cancel out moles. Let me update my shopping list. I need to cancel out the moles of sucrose. Now, I have the grams of sucrose periodic table. It's got grams divided by moles. The 342.3 grams per moles is the molecular weight of sucrose. It's a disaccharide, big sugar rings, ba-boom. 392, excuse me. I need moles to cancel out, so 392.3 grams divided by moles. Yeah, I wrote that in, maybe kind of funky looking and upside down, but again, I'm trying to make the unit cancel. So that is my main goal right here. Grams of sucrose, I got that straight from the shopping list, 40. The units of the question, Celsius, guided me to start here, and then I canceled out all the units. Now I'm going to pick up my calculator, and what this is going to tell us is this is going to tell us how much the boiling point was elevated. It's not going to tell us the boiling point. It's going to tell us how much the boiling point was elevated. Remember that the boiling point of water is 100 degrees, so elevated up from that. I hope this helps. Thank you.